I have chosen the element nitrogen. This is the periodic table of the elements. The periodic table tells you a lot about the chemical elements. Right here we have nitrogen. Nitrogen is in the 15th main group and in the second period. The main group tells us about the number of electrons in the outer shell. Nitrogen has therefore 5 electrons in the outer shell. The periods tell us about how many shells an element contains. The atom nitrogen has therefore 2 shells because it's in the second period. Nitrogen is the 7th element in the periodic table. It has a symbol N and has 7 protons and 7 neutrons in the nucleus. The shell model of nitrogen shows that it has 2 electrons in the inner shell and 5 in the outer shell. Nitrogen atomic mass is 14.007, which means that it weighs around 14 units. The ion has a neutral charge because it has the same number of electrons as protons. Here we have a chemical equation of lithium nitrate. On the left side we see the reactants, and on the right side we have the product itself. The 6 lithium atoms plus the nitrogen atoms are balanced on the right side. When you multiply 2 with 3, you have 6 like on the left side, plus you still have the 2 nitrogen atoms. Nitrogen is a colorless, odorless, and tasteless gas with a density of 1.25046 grams per liter. Nitrogen changes from a gas into a liquid at a temperature of -195 degrees Celsius. It changes from a liquid into a solid at a temperature of -210 degrees Celsius. At room temperature, nitrogen is a very inactive gas. It does not combine with oxygen, hydrogen, or most other elements. Nitrogen will combine with oxygen, however, in the presence of a lightning or a spark. The electrical energy from either of those sources causes nitrogen and oxygen to form nitric oxide. Nitric oxide is more active than free nitrogen. For an example, nitric oxide combines with oxygen and water in the atmosphere to make nitric acid. When it rains, nitric acid is carried to the earth, where it combines with the metals in the earth's crust. Compounds and polyatomic ions known as nitrates and nitrates are now formed. Here we see a nitrogen atom that wants to achieve the octet rule, to have a full outer shell. In the neutral atom, we see that it has the same number of protons and electrons. For nitrogen to fulfill the octet rule, it must get 3 more electrons. Now that it has 8 electrons in the outer shell and has achieved the octet rule, the charge has also changed. There is no longer the same number of electrons and protons because it has gained 3 electrons, which give the nitrogen a negative charge and is written N3-. 2 naturally occurring isotopes of nitrogen exist, nitrogen-14 and nitrogen-15. Isotopes are 2 or more forms of an element. Isotopes differ from each other according to their mass number. The number written to the right of the element's name is the mass number. The mass number represents the number of protons plus neutrons in the nucleus of an atom. The number of protons determines the element, but the number of neutrons in the atom of any one element can vary. Each variation is an isotope. Here is an experiment with nitrogen and water. He has poured 20 liters of liquid nitrogen into a container and adds boiling water. Because nitrogen is so cold that there is almost a temperature difference of 300 degrees Celsius between the hot water and cold nitrogen. This causes the liquid nitrogen to evaporate extremely fast. Because nitrogen as a gas fills almost 1,000 times more than in liquid form, there is formed a large volume of nitrogen gas. This gas is still quite cold, so the air around the released gas will also be cooled. There will precipitate water in the air in the area around the nitrogen gas and thereby create this cloud. The nitrogen goes from a liquid form to a gas form, which is written N2 in liquid form to N2 in gas form. Nitrogen is absolutely essential to all living organisms. It's an important part of all protein molecules. It occurs as a component of amino acid and nucleic acid like DNA and RNA. Proteins are the building material in all kinds of cells. They are also used for many other functions. For an example, all living organisms use hormones to send chemical messages from one cell to another. Hormones are proteins.